Hi there, this is a 4-part video where I will explain about USB Type C power delivery and its alternate mode. So let's get started. In the first part, we will be focusing on introduction slide, and in the second part, you will see the history of USB and its connector specification. Third part, we'll discuss about the USB Type C's power delivery, and finally, we'll see about the alternate modes. So let's get started. USB Type-C is an emerging standard for charging and transferring data over USB, and the data transmission speed can go up to 40 gigabits per second. Right now, it is included in devices like newest laptops, cell phones and tablets, and some watches, smartwatches. The designation C refers to the connector's physical form factor and its configuration. USB-C is a 24-pin USB connector system with a rotationally symmetrical connector. USB Type-C has a small form factor of less than 3 mm in height. PD, which is power delivery, is a specification for handling higher power and allows a range of devices to charge quickly over USB. It operates by facilitating a conversation between two devices to negotiate the power ratings and the requirements. It's more like a pizza shop where you will order something and it will get delivered. Similarly, here you will order 12 volt and it will be delivered. So it's just a handshaking process. Since it looks simple, but in actually there's a lot of procedure, there's a lot of protocol in the background which is quite mandatory to follow. So even though my explanation looks simple, but actually there's a lot of things which we should take care while doing this protocol handshaking for Type C PD. PD starts at a voltage of 5 volt and it is configurable up to 20 volt using a single standard USB cable. Type C PD can be used to transmit power up to hundreds of watts over a single USB cable, as well as parallelly it can also use the alternate modes. In order to truly use 100 watts of power over USB, we need a specific dedicated EMCA cable, which is EMCA, which stands for E-mark, which is electrically marked cable. The Type C active cable packed with an E-marker chip. As you can see, this E-marker chip here. So in this chip is used when the USB is in UDP and DFP mode, downstream port and upstream port. So this chip will give an information about the ID of the device ID, the cable ID, and the basic requirements, how much voltage it can withstand, how much voltage it can transmit, how much current it can handle. Because with the help of this EMCA, means if you get the confirmation from the EMCA, then only we can transmit 100 watts, or else our normal USB cable will burn. So this EMCA cable is very important to as a security measure, because we cannot just transmit 100 watts of power over a normal USB cable and it will end up in burning. Alternate modes allows for protocol other than USB to be transferred over a USB connection. Actually, normally if you take a USB cable, it's only meant to transmit data using USB protocol, but with the help of this alternate mode, we can configure it to transmit HDMI data or Ethernet data. Means it's more like customizable version. You can use the if you see the connector, we have TX and RX. We can use this interface to transmit HDMI signals or some other different kind of signals, and much more. So this is what the alternate mode is all about. So, and there's another one thing, even our USB cable is only meant to transmit 5 volt. This was the older standards. According to those standards, we are only meant to transfer 5 volt. Any charger which is providing more than 5 volt, it's more like violating the standards. But with the help of power PD, we are transmitting voltages above 5 volt. The alternate modes and the power delivery can be enabled using the power delivery protocol handshaking, which I said before, through vendor defined messages, VDM, which stands for vendor defined messages. So this will help them to discover and configure the devices to support different alternate modes and negotiate the voltage ratings. Single or multiple protocols can reside over a single Type C cable. If you could see, it's not like only one type of protocol you can implement. You can implement different protocols inside a single cable. Like, I'm not sure whether I'm doing a proper example or not. Let's say I2C, and you are also transmitting the HDMI data. Actually, according to a record, I saw that I2C is also being used for some configuration purpose, but I'm not sure whether it's being used in the customers. Currently it's available in market or not, I'm not sure, but still in research purpose they are using I2C to configure between the devices. I don't know how they are managing to transmit the data up to 1.5 meters or 2 meters, but still with the proper shielding it is possible. Okay, I think I moved out of the topic, and here we have a suitable example such as this device where it makes use of PD. I think so, it makes use of PD, and maybe, I'm not sure, maybe it might be using voltages above 5 volts. So if it is using voltage above 5 volts, then we can easily claim it as it is using power delivery. And here is a best example that this device uses more than one protocol. You can see USB protocol, and you can also find an HDMI, and some other versions will also have Ethernet port. So Ethernet, that's a specific, that's in my latest slides. So you can wait for my next video where I'll explain about this. So thanks for watching.